So we have a question here to solve today. We are supposed to prove that when we differentiate x cos x, we will get cos x minus um, x sine x. So let's see if we can prove that. So that is A. When we differentiate x cos x. Now remember that there are two functions, okay? X and then cos x. So that means we will employ the product rule. Let's first differentiate x and maintain cos. So you differentiate x, you get 1. So that will give you cos x. Plus, now we maintain x and then we differentiate cos. The differential of cos will give us negative sine x. So this implies that we have cos x minus x sine x. And that is what the question wanted us to do. So we are done. Let's move on to the B. What is the B part saying? It says that we should use our result from part. Okay, so when you are working a question and you see that, okay, use your result from part A, okay, do not omit that. It is really significant. Okay, now what is it? We use the result from part A to find the area of the shaded area. No problem. Now this is the shaded area. It starts from pi on 2 to pi. So ideally we can easily say that, well, let's integrate from pi on 2 to pi, and then the function we are dealing with is x sine x. So that would be x sine x dx. Right. So, but the question said we should go to A, and this is A. Okay, and A we were able to prove. So from A, what did we do? Well, we were able to say that the differential of x cos x is equal to cos x minus x sine x. What this means is that, okay, if we reverse it, that is, if we integrate everything here and we also integrate everything here, we should come up with something like x cos x, which is equal to let's integrate this cos. That would give us what? Sine x. Yeah, good. Then let's maintain the integral sign on this. So we have the integral of x sine x. Now when we do this, you could see that something similar is being observed. Look at this. Look at what we have here. Compare it to what we are supposed to do here. Do you see the similarities? Yes, we are dealing with x sine x, x sine x. So that is why the question said start from A. Okay, so whenever you see from A, I mean, just go there. There's a clue over there. All right, so let's wrap this thing up. So let's make the sign, the integral of x sine x a positive, because it's now what? Negative. Okay, so let's make it positive. That would mean that we have the integral of x sine x dx will be equal to sine x minus x cos x. Right. So what this means is that if we integrate what we have here, this is the answer that we get. But the question says we should integrate from pi on 2 to pi. Right. So that is what we would do. So we are going to integrate from pi on 2 to pi. But since this is the answer that we get from integrating this, then we have pi on 2 on pi. Okay, so what do we do? Well, we have sine pi minus pi cos pi, okay, then minus sine pi on 2 minus x, which is pi on 2 cos pi on 2. So now sine pi is 0, then cos pi is -1. Okay, cos pi is -1, so times negative pi will give you positive pi. Right, now sine pi on 2 would give us 1. Then since cos pi on 2 is 0, so that part will be 0. Now this would mean that our answer is pi minus 1. Okay, but remember that what we are dealing with is an area. Okay, we are dealing with an area, so we treat it as such. So you add square units. Okay, right. So the summary is that whenever you are given a question and there's a followed up question asking you to go to part A, please go to part A, because when we went to part A, we could easily integrate and then solve and find our answer as pi minus 1 units squared.